Okay, so let's go ahead and get started with the second part of this video introduction to engine performance overview. We left off right here. Let me go ahead and share my screen to, and here we go, just like that. And let me see here, let's get rid of that. And, okay, so let's get started in this next section. Okay, so the next section, it's asking us, again, some simple questions. This is a phrase that some professors here at Skyline came up with actually, and I was part of this. And we came up with this phrase, and we call this phrase is, we want to ask you to please answer the question, what does the letters DEEP represent pertaining to engine performance? So think about some of the phrases in automotive and DEEP, okay? Okay, so, and this is gonna have to do a lot with what we're talking about as far as what engine performance is, okay? So I don't expect you to know this, but you will. And this is a way of thinking about, again, about engine performance and what ties into it, okay? So one of the things that you can think about engine performance is when we think about DEEP, we think about drivability, okay? Drivability simply means the ability of the engine to drive smoothly, to idle correctly, to start when it's supposed to start, not to stall, things like that. Simple drivability, okay? Is the vehicle drivable? That's what drivability stands for. Drivability is also a term that we use when we talk about a person's title, okay? I was a drivability specialist for many, many years. And that simply means the engine performance guy, okay? Before I was a drivability specialist, they used to just call me the tune-up guy, okay? But drivability specialist, again, that's somebody who deals with diagnosis of the engine performance system, computer controls, ignition, fuel system, that's called drivability, okay? The next letter is E for economy, okay, economy. We have to make sure that vehicles' fuel system is performing correctly, ignition system, so that we have the proper fuel economy, okay? We have the correct miles per gallon, very, very important, okay? Hopefully you can think of what the next letter would deal with, has to do with emissions, okay? The correct emissions. So I always tell people to think about it this way. When we talk about, hey, you know what, if we add a different spark plug, or if we add some special kind of additive, we can get more lower emissions, better economy. Think about it this way. They have engineers, okay, that these engineers, they have to every year, they have to be able to raise the economy, okay? They have to raise the economy of the vehicle higher and higher. I don't know if you've heard, but by 25, they want vehicles to be up around the 50 miles per gallon range. That's unheard of. Well, the only way they're going to do that really is if the vehicles are hybrid, right? So that's what the engineers come up with, because they can't come up with any other solutions. And then emissions, they have to lower emissions. So they have to up economy and lower emissions every single year. That's very difficult to do, but they do it, okay? And you know, when you think about emissions, think about the 1970s, okay? In the 1970s, when they were being very strict on emissions, that's when basically the smog check program started, okay, way back in the 70s. I know most of you weren't born yet. I was there. I was actually a high school student, okay, in the 70s. And during the 70s, they were trying to lower emissions even more. Well, they couldn't do it anymore by changing engine configurations or by changing the amount of fuel. So what did they come up with? Some engineer thought outside of the box, okay, was able to come up with something very, very creative that lowered emissions. It was a game changer. Can anybody think of what that was? What that was the catalytic converter, Okay, if you guessed catalytic converter, you're 100% correct. The catalytic converter was invented or implemented in the mid 70s, and that was a game changer. That was an engineer thinking outside the box. Everybody was thinking, how can I change the configuration of the engine? Can I put in a smaller carburetor? Can I put higher compression? What can I do? Let's make the car smaller. All of that was going on, and an engineer said, wait, what if we treat the gases after they come outside the engine, okay? That does nothing for economy, right? But it lowers emissions, and that's what they were worried about. They were worried more about the emissions. So thinking outside the box, they were able to lower emissions, okay? And then performance, okay? Because I don't care how much economy you get in a vehicle or how low your emissions are. If the performance is not acceptable for the customer, it isn't going to happen. So the performance has to do with, like, when I step on that throttle to pass that diesel as I'm entering the freeway, does it respond correctly? Okay, does it give me the driver expectation that I think that this vehicle should have? Of course, many times the driver expectations far exceed what the vehicle was designed to do. But if by all means, if the vehicle is a sporty model, then you expect it to perform as advertised, right? If you expect that thing to go to 0 to 60 in under 4 seconds, which many cars do nowadays, right? Then it should be able to do that. Why it will not do that is our job. We have to figure out drivability. We have to figure out the correct economy. That is, why is it using so much fuel? Okay, that it has a proper emissions and that it performs correctly. That's our job. Okay, in this class, that's basically what we're going to do. We're going to make sure that the vehicle performs correctly. Okay, has proper drivability, economy, emissions, and performance. Okay, so moving on. Okay, so what I want you to do in your words, like I just mentioned, what do these words mean? So on your worksheets, you're gonna need to describe those. Okay, and I gave you my version. Please do it in your own version now. Try to tell me what that means to you. Okay, what drivability, economy, emissions, and performance mean. So here's my definitions. Okay. All right, so I had talked about a triangle. The other way to think about this is as a representation, right? We have to make sure that we have volumetric efficiency. We got all that air coming in at the correct time. These two go together, right? Volumetric efficiency and fuel, the air and the fuel go together. So that's actually one on the left-hand side here. And then we have ignition and we have compression. All of these have to be functioning at their optimum. If any one of these is lacking, let's say we have a restriction and we're not getting enough air into that system. Well, if we're not getting enough air into that system, okay, then we're gonna have too much of this guy. We're gonna have too much fuel. Not only that, we're not gonna have enough air for it to be compressed correctly. So no matter how good the ignition system, it's not gonna perform as designed, okay? Same thing with fuel. If we have too much fuel or not enough fuel, if we don't have enough fuel, then we're gonna have the air fuel balance will be upset, okay? We will not have enough, we'll have too much air to burn with that if we don't have enough fuel, and we will not be able to have that same amount of change of fuel into power, okay? So all of these have to work in conjunction. We have to have the proper amount of air and fuel, okay? The two left go together. We have to have the correct ignition, good spark at the correct time, and then we also have to have proper compression, Okay, moving on. Okay, so again, write down on a piece of paper the best answers for the following question. What are the 6 essential requirements for building a basic electrical circuit? Okay, so for building a basic electrical circuit, what 6 requirements are needed? Okay, so start writing those down. Please excuse me while I take a sip of water. Okay, so what are they? So they are, you have to have power, right? You have to have battery or alternator. You have to have power. You got to have circuit protection. Okay. All electrical systems have some kind of circuit protection. And I know it says basic electrical circuit, so you can argue and say, well, all you need is basically power, ground, and a load. Yeah, but I'm talking realistically, right? Realistically in a practical sense, because yeah, a basic electrical circuit would simply be that, power, ground, and a load, and something connecting them, right? A conductor of some sort, piece of metal. But right here, we're thinking about, again, an automotive circuit, right? Something that's actually in use. So yes, we have to have a power source. In the case of an automobile, we have a battery or alternator after the vehicle is running. We have circuit protection, a fuse or fusible link. We have a switch, right? Typically we have something to turn it on or off, a control. We have a load. Something has to use up the power. We have to have something, a load in the circuit, or else the circuit will short circuit, right? You can't have a non-loaded circuit. We have wires or conductors, right? They are typically insulated conductors. Okay. We have a common ground that links back to the source, right? So we have these 6 requirements of an electrical circuit on a practical electrical circuit, okay? So think about that. So let's think about a basic electrical problem, okay? Again, hopefully this reminds you, basic electrical problem. Remember here we have, here we have the battery source, we have a conductor, we have a load, conductor, and a ground. No switch, no fuse, okay? So this is just a basic circuit, okay? It says here basic electrical circuit in a realistic format, and a basic electrical circuit just in a cartoon, right? So list 6 common problems that could possibly occur in this circuit. What are 6 problems? There are 6 different electrical problems that could occur. And we're going back over electricity because automotive performance deals greatly with computer controls, and we have to have a solid foundation in electricity to be able to do well in this course, okay? If you are, if maybe you took electrical 2 semesters ago, or maybe it was, you didn't get the most out of it for whatever reason. I know that most of you, if not all of you, by now had Phil. Phil does an excellent job in teaching electrical. I, by the way, when I started teaching here at Skyline, taught electrical for 2 semesters, but then the engine performance became available, and that's what I really specialized in. So I moved over. I like teaching electrical too. I just like engine performance more. But I know that Philip does an excellent job. Before, I think last semester was the last semester where I had actual students that were in my class in electrical and then come through the program. So this year, I don't think I have any students that were in my electrical program, unless you stepped out of the course for a while. By any chance, if there are any of you who were in my electrical class, let me know. I didn't see any names that I remember, but if you were in my electrical class, let me know. I'd like to reminisce a little bit. Okay, so anyways, list 6 common problems, okay? List 6 common problems that can occur in this electrical circuit. So I'll give you a second to do that. Think about that. Think about 6 basic electrical problems that can occur. Some are easy, some are not that easy. I'll give you a few seconds to think about that, okay? Okay, so let's start listing those up. Some of those should be pretty easy, right? By the way, my philosophy of electricity, just so you know, is that, and through my experience, is that 90% of the time, okay, you can take this and put it to the test, okay? 90% of the times when you have any kind of electrical problem, it'll be associated with either the power or the ground, okay? The power or the ground. It is typically not the component, okay? So you can take that to the bank. Whenever you're working on an electrical problem, okay? Remember, 90%, 9 out of 10 times, if you work on 10 cars with electrical problems, 9 of the times, it's gonna be a power or ground problem, right? Keep that in mind whenever you're working on any electrical circuit, okay? So we always make sure, right, that we have proper power, proper ground. If we have that, then we move on to the circuit, okay? We usually do that. Our diagnosis goes in that order as well. Power, ground, load, right? That's how we typically do our diagnosis in electrical, okay? Anyways, moving on. So what are the problems? We can have an open on the source side of the circuit. So again, no power, right? There it is. We can have a voltage drop on the source side. In other words, not enough power, okay? So we can have no power or we can have not enough power, okay? Today's systems, if they don't have the exact amount of proper voltage, whether it's too low or too high, the computer control system will simply shut it off and say, I'm not playing this game, right? Because I don't want to damage my internals. So it'll actually shut the system off, okay? So today's system, very, very picky, in lack of better terms, as to the correct amount of voltage, okay? Then we have open on the ground side, okay? Kind of like number one, but on the ground side. And then a voltage on the ground side, which is the same as 2, right? This can be a little confusing. Voltage on the ground side, that just means that you have a poor ground, okay? So number 1, you have a complete open on the power side. Number 2, you have a voltage drop, not enough voltage. Number 3, you have an open on the ground side. Number 4, you have excessive resistance on the ground side. That's basically what that means. Number 5 says an open load. The bulb is burnt out, okay? And number 6 is a short circuit. Power finds ground ahead of the load and blows the fuse. And then it becomes an open circuit, like number 1. By the way, guys, whenever you're thinking of an electrical circuit and it becomes complicated, right? When you start looking at electrical circuit and it becomes a little bit, I don't know, confusing, always go back to this perspective. All it is an electrical circuit. It has to have power on one side, a load, and a ground. Okay, you can dial in the other components, but always think back of it like this. Okay, keep it that simple. You keep it that simple, you will not overwhelm yourselves. Okay, so many times when I'm diagnosing an electrical problem, I draw the bulb circuit again. I draw the bulb circuit and I compare it to my circuit. And that helps me diagnose my system. And it helps me to remember that I have to keep this simple, okay? I have to keep this simple. Okay, moving on. So right now we're gonna talk about automotive pollutants. Automotive pollutants, okay? What does that mean? That means unhealthy emissions coming out of the vehicle, okay? So on automotive pollutants, I want you to go ahead and write down on a piece of paper the answers to the following question. What are the 3 major pollutants caused by automotive exhaust emissions? So what 3 major automotive pollutants are caused by the automotive exhaust system? Please take a second and write those down, okay? Take a second and write those down. So most of you will probably get this because you guys know, you guys live in California. California is one of the most, has the most strictest, let me say this correctly. California has the most strict ordinance on automotive emissions. We have the premier automotive smog testing system. Every state in the United States follows what California does. Some change it a little bit, but they're always looking at us to see what we're doing next, okay? because we have a huge problem here with smog, right? So we're always trying to get a perspective, okay? Remember, guys, like I told you at the beginning of this course, this class satisfies your bar level 1. So you're about, when you finish this course, you're about 50% ready to go take your smog test, which is a big deal. Okay, it's a big deal. Okay, so what are the 3 pollutants? They are hydrocarbons, okay, carbon monoxide, okay, and oxides of nitrogen, okay? So 3 major pollutants are hydrocarbons, carbon monoxide, and oxides of nitrogen. Next, what I want you to do is I want you to, in your own words, briefly describe what each word means to you as the owner of a motor vehicle, or the way I like to think about this is how would you explain what that is to a consumer? Okay, that's what you really need to do, right? Because, you know, you being a owner of a motor vehicle is besides the point, okay? Now you're a technician, okay? And you should and will have to explain to either consumers, to the shop manager, to somebody what each of these are, okay? So you should be able to describe what each of these are, okay? So hydrocarbons, or they're called, they're abbreviated HC, okay? HC, which is 1 molecule of hydrogen and 1 molecule of carbon, okay? Okay, are molecules that are not burnt. So you can just say that hydrocarbons are raw fuel, It went in, nothing happened, it came out. Okay, simple as that. And that is measured in parts per million, or ppms. I'll describe what that is later, okay? Next we have carbon monoxide, okay? Carbon monoxide is when the combustion process lacks oxygen. There's not enough oxygen to burn the fuel, okay? And it is measured in percentage. And then finally, we have oxides of nitrogen. And oxides of nitrogen are created when the combustion temperature reaches, actually, that's a misprint, guys. Okay, that's a misprint. That's actually should be 1300 degrees. Okay? That should be 1300 degrees. So please remove that, okay, and put in the correct number. Okay, so let me switch back to my screen so I can kind of give you a little rundown on each of these, okay? So let me see here, like that, and I'm gonna, oops, go like this. And now I'm gonna go like this. Okay. All right, so let's talk about, oh, I knew that was gonna happen. Sorry about this. There we go. Okay, so as I mentioned, hydrocarbons are abbreviated, oops. Okay. There we go. Hydrocarbons are abbreviated HC. Let me get this cleaned up here. That is 1 molecule of hydrogen, 1 molecule of carbon. And carbon monoxide is abbreviated CO, 1 molecule of carbon, 1 molecule of oxygen. And then we have NOx, okay, or oxides of nitrogen. So those are typically, it's abbreviated NO and with an X, like so, right? So, and that's not 1 molecule of nitrogen, and where it says oxygen, notice that it has an X, right? So the X is a variable. It just means some molecule. So it can be 1, 2, 3. So it could be NO1, NO2. It doesn't matter. as long as it has a molecule of oxygen attached to the nitrogen, it is oxides of nitrogen, okay? Everybody get that? So that's what that X means. It's just a variable, like in algebra. We don't know what that is. It can be any. It could be NO1, NO2. It doesn't matter, okay? So we know what these are. We know that hydrocarbons, unburned fuel, raw fuel. Carbon monoxide is partially burned. Remember that carbon monoxide, we ran out of oxygen. We ran out of oxygen. And that's what caused the carbon monoxide. So if we ran out of oxygen, why would we run out of oxygen? How does that work? Why would we run out of oxygen? Well, the only way that we can run out of oxygen and the only way that we're going to create carbon monoxide if the mixture is too rich, okay? That means that either we have too much fuel or not enough air, okay? Hydrocarbons can be caused by various mishaps, okay? And one of the ways that hydrocarbons can be produced, okay, is that hydrocarbons are produced because of, one of the most common is misfires, okay? And we'll get more into this a little later, hopefully tomorrow during our live, or whenever we do our next live Zoom meeting, we'll talk about that. But misfires is a common one, and I'll get more into that later. And then oxides of nitrogen, remember, excessive temperature and pressure are what creates oxides of nitrogen. Now, what I want to talk to you real quick about is this. When we're looking at an air-fuel mixture, okay, coming into the engine, sorry, this application is free, so that's why you would get all this stuff. So when we're coming into the engine, we have air, right? We have air and we have fuel. That's what comes into the engine, right? We have air and fuel that comes into the engine. So air is composed of mostly of nitrogen, okay, and oxygen, okay. Fuel is composed of hydrocarbons, okay. Remember I said hydrocarbons was raw fuel? It sure is, right? So fuel is hydrocarbons, air is nitrogen and oxygen, and small traces amounts of other gases that are not important to us. Nitrogen we have at about 78%, huge amount of nitrogen. Oxygen is the remaining percentage, right? So just about 21% of oxygen, okay? So, and then again, the fuel is hydrocarbons. Now, here's what happens. Here's what's supposed to happen, okay? So if we get the hydrocarbons and the oxygen to burn correctly at that correct air-fuel ratio, you guys remember what the correct air-fuel ratio was? Well, if you remember, if you're saying 14.7 to 1, you are correct, right? So if we get it to burn at the correct ratio, now nitrogen, don't worry about the nitrogen, because nitrogen basically by itself is harmless, right? We're breathing a big amount of it every single day, but it's harmless, okay? It's what's called an inert gas, inert, I-N-E-R-T. That means inert, you can't see it, you can't taste it, it's just harmless by itself, okay? That being said, when it mixes with oxygen and forms oxides of nitrogen, then it becomes very, very bad, but we'll worry about that later. So for now, we got hydrocarbons and oxygen are the main players in this formula, okay? So if we get hydrocarbon and oxygen to mix at the correct amount, okay, what ends up happening is that we have the hydrogen will automatically combine with the oxygen, okay, so it'll be pooled, the hydrogen will be pooled to the oxygen. This happens naturally as in the combustion process. The hydrogen is pooled to the oxygen, okay? Not only that, it doubles up, okay? And it ends the way that it pulls the oxygen is that it forms into two molecules, okay? And then it pulls a single molecule of oxygen and becomes this. Does that look familiar? Right, H2O, water, okay? So the molecule is separated from the carbon, okay? And it binds with the oxygen, doubles up, and forms water, okay? The other, what's left is the carbon, okay? So then we have the carbon, okay? The carbon doubles up and pulls more of the oxygen, because remember, we have a lot of oxygen, right? We have 14.7 to 1. So we have the carbon, okay? And then we get some more oxygen, and we have, whoops, I'm sorry. It doubles up the oxygen, and now we have carbon dioxide. So we have water and carbon dioxide. And carbon dioxide, by the way, we have carbon dioxide, which is basically what we as humans exhale after we use the oxygen, right? We inhale oxygen, or we inhale air, but we use the oxygen, and we exhale carbon dioxide, okay? Carbon dioxide, by the way, is also what green plants, okay, take in to produce oxygen. So this is what comes out, okay? And then we also get this guy, the nitrogen comes out, but that just comes out as harmless heat, okay? That comes out as heat. So we have oxygen, carbon dioxide. This happens when we have the proper amount, okay? My emissions instructor used to say that when everybody has a dancing partner, this is what occurs, right? We have H2O, CO2, and nitrogen in the form of heat, okay? That's what the air-fuel ratio has to do, okay? Or has to do for our purpose. And I'm gonna try this again, see if I can do this. I'm getting good at it. All right, so let me go ahead and stop this share and go back to our presentation. Okay, and back to our, here we go. Okay, so so that's what happens there, okay, with these three pollutants. Okay, moving on. And then here's just a quick sheet that you can look at as far as the gases, what they are, a little bit more of a definitive view of it. You can look at this yourself. When you guys get your binders on Wednesday, you guys will have this copy. I'm not going to go through it. You guys can read that yourselves. Okay. So sticking with the topic of automotive pollutants. Actually, we're going to stop there for a second. We're going to stop there for a second. I'm going to take a break, and then I'm going to come back, and we'll finish the section. We'll do video 3, okay? And go like this, and we'll stop again. We'll stop it for now. I'll stop recording, and you guys will come back and do video 3. Please continue working on your worksheets, and I'll see you guys in a few minutes.